Hello everyone and welcome to the channel. My name is Brandon Joza and I'm a solution architect at Red Hat in the Telco Media and Entertainment Group. Specifically, I'm a Tiger team member, which means that we handle a lot of the technical engagements at Red Hat during the sales initiation process. So what I'm going to cover today is a topic that comes up quite a bit. It's the assisted service or assisted installer provided on console.redhat.com. And specifically, we'll cover two use cases that come up from time to time, which is how to set static IP addresses using the assisted installer API, and also what if somebody wants to use their own CNI? Let's say they use Calico or Cilium. How can they install those as part of the assisted installer service? So let's go ahead and cover these things, and we'll go ahead and get started here. So you may ask yourself, what is the assisted installer? The assisted installer fits in a unique place in between IPI and UPI installation methods. So IPI being installer provisioned infrastructure and UPI being user provided or user provisioned infrastructure. So what IPI is it's typically used with cloud providers. So there's existing infrastructure that can be leveraged. So if you're using AWS, GCP, Azure, those things, those services have an API that can be used to provision infrastructure, and then the OpenShift installer can use that use that infrastructure to then deploy what it needs to deploy the OCP platform. With user provisioned infrastructure, it's slightly different, where the user must provide things like DNS, DHCP, Pixie boot in the case of, let's say, a bare metal environment. The ancillary services that are required to actually set up the infrastructure. So what we're going to cover today is a third option, which is the assisted installer. The assisted installer can be found at console.redhat.com. And if you go to /OpenShift/assisted installer, what you'll notice is you can create a cluster simply by going through the UI, creating a few parameters that you may want to use. So in this case, we'll just use example.com. And what we'll do is we'll use a single node OpenShift environment just to get this done rather quickly. You select your version, you click next. And the way this works is very similar to Kubernetes. It's a declarative model fronted by an API. So you tell the API what you want to do, and that can be done in a number of different ways. I've written an article where you can use curl just against the API directly, or you can use a utility. Today, what we're going to be covering is a utility called aicli. It's written by Red Hat's own Karim. Karim has written this utility, and it eases the installation of or modification of assisted installer clusters. The way that this works is you tell the API what you want your cluster to look like or what components you want to have in your cluster, for example, a custom CNI, and then you generate an ISO. And when you're generating an ISO, you give it a public key so that way you can manage the nodes that come up in that environment and then assign them different roles, either a control node or a node, a worker node. And then you generate the ISO. And then you insert that ISO either virtually, if you're using a VM like we are today, or your bare metal. So you can use Redfish or some other DRAC if you want to install that media, and then you can install the cluster that way. And then you essentially just click next and so forth. But where the UI lacks is where the aicli picks up, and that is customizing the deployment. So for example, if you want to give it a custom IP address, you're not using DHCP on a broadcast domain and you want to assign the IP address statically, then you need to do something a little bit different using an nm state file, which we'll go over in a moment. Or let's say you want to install, like I've been mentioning, a custom CNI. How would you do that? Because you obviously need the CNI deployed with the cluster at the time of instantiation. These are the things that we're going to be covering today. And I wrote a gist, which will be linked in the description below. And this just covers exactly how to do this. So let's go ahead and cover this documentation and run through it and see how you can do this within your environment. And if you have any questions or comments, please leave those in the description below. Or if you have any suggestions for new content, I'll create some new content, answer any questions that you want with future upcoming videos. Leave those in the comments as well. So let's go ahead and get started here. So I've provided a bunch of links at the very top that I think will be useful as you're learning about this utility. But essentially, going over them really quickly, the first is going to take you to the actual console.redhat.com where you can deploy an OpenShift cluster yourself, right? So in this case, I deployed a cluster. Here's the cluster ID at the very top. If I refresh this page, then you'll notice that I have two clusters, one that I deployed earlier, and then the one that I just created a second ago, as I was showing you before. So we'll go ahead and delete the test, so we don't need that. The second is a blog that I wrote about with the aicli utility, and you're welcome to go through that blog as well as the aicli GitHub repository. And then today, to mix things up a little bit, what I'm using is a virtual machine that's actually running on vCenter, and we're going to use a utility called govc to manage that VM and then deploy OpenShift on that VM. And the reason why I'm using this is because we can integrate, when I say we, I'm talking about Red Hat in general, can integrate with any number of cloud providers, right? So in this case, what we're going to do is leverage VMware, and we're going to deploy OpenShift on VMware. And I've gotten asked about this utility before in the past, and so I'll provide this and kind of kill two birds with one stone, show how govc can be used, and then also deploy OpenShift with custom networking and a custom CNI. Then I provided a link on nm state and what the nm config looks like in OpenShift. And then I provided some links to Calico as well. And we are going to be setting up BGP peering, and I'll show you how that works as well. So the first thing that you'll be interested in is filling out the variables to match your environment. So I've created this, or crafted this documentation rather, to where it's pretty much just cut and paste. So you can like copy these variables here and apply them into your terminal. And then what we're going to do is we're going to make some directories. And I'll explain what these directories are for. Right now we don't have anything in here. And we're going to make an auth directory, which is where we're going to place our authentication files. This is standard OpenShift practices here. So if you were to create an IPI or a UPI cluster, you'll have an auth directory that includes your kubeadmin password and also your kubeconfig. We're going to place those in here as well. There's also an ISO directory where we're going to load the virtual media, and what we're going to do is upload that virtual media to vCenter, and then we're going to boot the virtual machine from that virtual media. And we'll show you how that works as well. Then we're also going to include some networking examples here. We're going to include a couple Calico manifests, one to disable BGP node-to-node mesh, and then we're going to configure a BGP peer, as well as we're going to drop the Calico manifest into what's called a manifest directory. And this is also very standard to an IPI or a UPI deployment, as the manifest directory is going to be the files that's included as part of the instantiation for the cluster. So once we've done that, what we're going to do is create the cluster from this, or when I say this, I'm talking about these variables that we just entered. And what you'll notice is we are giving it the cluster name here. We are locating the pulse secret. So the pulse secret is listed as a file here. It's this OpenShift -pull-secret.json file. We're giving it the CIDR ranges for both the pod and the service networks. And then we're giving it the host prefix. In this case, I believe it's at /23 here. And we're going to define the network type as Calico, which is the same as defining it as none. So there's only two networks that are really recognized, and that is OpenShift SDN and Oven Kubernetes. And if you're not going to deploy one of those two, we're assuming that the user is going to define their own networking and provide their own networking manifest for the CNI, right? So we're turning off VIP validation, or I'm sorry, VIP allocation for VIP DHCP allocation. which means that we're not using DHCP in this broadcast domain, and we're not going to get an IP address to assign to the VIP or the ingress piece. We're doing user managed networking. We're giving it an OpenShift version of 4.8.12, and we're setting the high availability mode to none, which means that this will be deployed by default as an OpenShift all-in-one cluster or all-in-one OpenShift environment. Now what we're going to download here is a sample network config that we're going to use with this deployment, and it's a bonding configuration. So if I were to, let's say, look at network example for the bond, what we'll see is we've got our DNS resolver, so our DNS server that's located here. We're creating a bond interface and making sure that it's up with an IP address of 192.168.60.225. Prefix is /24, so it's just a standard class C subnet. We're enabling that as well, so we're enabling IPv4 when we do this. And we're setting the link aggregation mode to active backup in this case with a with the two interfaces here, ENS 192 and ENS 224. Now it's really important that your MAC addresses match with these interfaces when they come up. You can have multiple hosts defined in a single static network configuration here that we're going to upload. In this case, we're just doing one, but you can define multiples in here. And we're setting a default route of 192.168.60.1 because this is just a broadcast domain of a /C, or class C, sorry. So we'll quit out of there. We've got that. Now, since we've downloaded that, what we're going to do is we're going to update the cluster for the network type, which is Calico. And I should show you that with this command that we created up above, we have this cluster here too. So if we do an aicli list clusters, what you'll notice is we've got a new cluster here called CCD, and that is ccd.ai.telco.ocp.run. You notice the status is waiting for input, so we're actually providing these values to the API, and we're configuring the cluster on the back end. If I were to look at the cluster here, let's say I refresh this page, we'll see that the cluster exists here now. It's CCD, and it's really just waiting for a host to check into the API. That's where our bonding network interface comes into play. So what we're going to do is we are going to create an ISO with the cluster name, but we're going to give it a parameter file, a special parameter file called an nmstateconfig file. And what that's going to do is configure the networking for this host. So when we download our ISO, the networking is included with that ISO, and when the host boots up, it's actually booting up with the specific networking that we want. So what we'll do is we'll look at the info for the cluster, and what we'll be able to see is even though you see that the network type is defined as OpenShift SDN, we're actually doing an install config override, and we're saying the network type is actually going to be Calico. So that's one thing to note here, is that we've made that change, and we can see what that change looks like here. Okay. So the next thing that we're going to do is download our ISO into the ISO directory. Remember, we created an ISO directory here. So we're going to download this ISO using the cluster name into the ISO directory as a path, which is this -p here. And that's going to download the ISO. Now, in the meantime, what we're going to do is we're going to get into managing the host itself, right? So we've got a VM defined in the name because I've used this host probably a dozen times. I'm calling it infra.demo.ai.telco.ocp.run. The data center is going to be in a data center called Jinkit with a dstore of data store 11-01. And the data store ISO location, I've got a boot folder created where I keep all my boot media. So what we're going to do is we're going to copy this information, and we're going to export this out, or not export it, but we're going to configure these variables for our shell. And then what we're going to do is we're going to say, okay, if there is any installation media for this VM hostname, which is this guy right here, I want you to eject that virtual media. And so what we're going to do is eject that media here. Now, I've run through this process of creating a cluster with media. So I'm going to do a data store remove of the media that currently exists there. So if there is any media named ccd.iso in the boot directory, I wanted to delete it, and it looks like it's already gone. So there is no boot /ccd.iso. So what we're going to do is export these out again, this time including a couple more. So the variables that we're going to define here, the new ones rather, is a vCenter config file. And what I'm using that for is to authenticate me against the vCenter environment. I'll need to authenticate against the vCenter environment so that way I can, let's say upload an ISO or manage this host. I'm already authenticated, so I'm gonna just show you what this looks like. But if we wanted to authenticate against this, we can do like a source on this file, and I have included this in the description of the gist. And the way that I have this written is that it'll actually take input and then record that as a variable. And then that variable can be called, which is your password, right? So when you log out of the shell or or reset your shell, then your password will be gone. So it's not a good practice. It's just one that I'm using rather than showing the password on the screen in the file. This file is actually located down below. So if you wanted to see what this looks like, it's these commands right here, and you can see that I'm doing a govc about, which tells me about the environment after I've done the login command. So now what we're going to do is we can look at the host using govc, and that'll tell us some information about the host itself. And in this case, what I'm doing is this host happens to be a Dell server. There's 32 CPUs in this host, and there's plenty of memory available as well. So what we're going to do is power off the device, and I am going to make sure the machine is powered off. I'm going to upload the ISO here that we downloaded into the ISO directory, and you can see that that's being loaded. And that'll take just a few moments, and we can actually see this in here too. We'll be able to see once the host is up, or once the ISO is loaded, we'll be able to see that in our console. And once that's completed, I'm going to change the boot order, and we're going to come back to this because there's a point where we'll need to change. I'm actually forcing the boot order to be CD-ROM and then the disk. But once we've started the installation process, I'll need to reverse this because I'm manually overriding the boot order. But in all likelihood, what would happen is the assisted service or the assisted installer installation media will reverse the order anyways by default. That's what it's supposed to do. So what I'm going to do is insert this ISO into the virtual media for that host, and it's been inserted, and then I'm going to power on the machine. And as this machine is coming up, what I'm going to do is ping 192.168.60.225. And I'm also going to see if the host is coming up. It looks like it is coming up. Arcos is loading. And once I get an IP address, I'll be able to see this in two ways. Number one is Arcos is smart enough to tell the user what the IP address is just in the login screen, because you won't be able to log in directly on the CLI. It's using only SSH public keys to log into the host. So what Red Hat does is it will tell you, devs have configured it to tell you what the IP address is. And sure enough, it is 192.168.60.225. And we are responding now So we can SSH as the core user to 192.168.60.225. And this is where you can do things like the first thing I typically run is like a journal ctl-f just to see any output that comes along. But there's not going to be much going on until we actually tell it to do something. So what's happening is this host is coming up, and what it'll do is check into the assisted service API here, and it will show up as a host, and then we could give it a role. So since we're doing a Snow installation, I can't give it any other role than a master role, and that ends up putting it into a master worker role. So it can be a master, or we say control plane now. It can be a control plane node, and it can also be a worker node as well, right? So it takes on that dual functionality. Now, the reason why we're getting an insufficient here is because the assisted service doesn't want to accept hosts that are all local hosts. So by default, Arcos and the installation media will name the host localhost, and you'll need to change that. And I'm going to show you how to change that here in just a moment. But before we get to that, what I want to do is continue configuring the assisted service installation here. And I want to upload the Calico manifests. So the first thing we do, remember, we have this directory already, so I don't need to create the directory. You can type this if you really want to. But what we'll do is we'll create a folder called manifests, and then you'll open this link right here. So we'll open this in a new tab, and this goes straight to the Calico documentation. And we're going to copy this right here. You'll notice that the first thing that the Calico developers ask you to do is to create a manifest directory, right? We're going to skip that, but we're going to create these files right here, okay? And what that's going to do is that's going to download each of the Calico manifests into the manifest directory. And then we're going to instruct the assisted service installation, this here for the cluster, to upload that directory and include it with the installation. Okay, so if I do a tree now, there's all my manifests. And what I'm going to do is come back here, and I'm going to create a folder with this installation called manifests. So it'll be included with the deployment. And the directory is called manifest here locally. And so what I'm essentially doing is I'm doing a curl command. I'm base 64 encoding each of these files in the background and sending that data as part of the deployment. Okay, so if we wanted to validate that each of our files have been included, what you can do is run a ACI CLI list manifest on the cluster name, and sure enough, this has been uploaded to, or each one of these rather, have been uploaded to the manifest directory. So it's included with the deployment now, which is great. Now what we want to do is we want to update the machine network. Okay, so the network that the physical interface is attached to, that's what we want to configure this as. Okay, so again, we know that's 192.168.60.225. So if I did a AI CLI cluster info on CCD, or sorry, it's info cluster, info on cluster CCD, what we're going to see is that the status still, let's do this, let's do list clusters is what I really wanted. We'll see that the status is still pending input, okay? The reason for this is because if I do a AI CLI list hosts, what you'll see is this is still localhost, right? And it's insufficient because the localhost is not a valid name. We need to give this a unique name. So what we're going to do is change the machine network for the local connected Ethernet broadcast domain. So 168.60.0/24, right? We know that. And then what I'm going to do is I'm going to I list the hosts here. Now what I'm going to do is give it the host ID that I want to change. And that's this host right here. And then what I'm going to do is update the host name to what I named the VM host name. So we can see that this node right here that ends in 02E34 has been renamed infra01.demo.ai.telco.ocp.run. So if I were to do a list on hosts, now we'll see that the name has actually in fact changed. And now the status has changed to unknown status, and it's a role of master, in this case a master worker, or really control plane in Node. So what we can do now, once we're in this known state, we can do an installation of the cluster. So before I start that command, I'm going to go to the UI here. We can see that everything is ready, and we see that it is in fact reading this as 16 cores, 32 gig of RAM. It notices that there's disks that are available to install. It even sees the installation media. And what we're going to do is start that install. Now we're not completely done here, because what we need to do is change the CD-ROM boot order, like I said before. So what we're going to do is change the boot order from CD-ROM disk to disk CD-ROM. So when the host reboots, it reboots to the proper order. It reboots to disk rather than the CD-ROM. So what we're going to do, I'm going to let this continue for a little bit. And once this is all complete, I'll come back, and then we'll start getting into configuring Calico itself, and we'll look over the cluster, and we'll go over what else needs to be changed in order to have pods and services that are reachable directly on the network using BGP and disabling node-to-node mesh. So I'll see you in a moment. It took almost exactly half an hour, so this cluster really started. By the time we actually kicked off the process, it was about 2:20, and noticed it finished up at about 2:50, just slightly before, and then I started recording. So we can see that this cluster has been deployed. Now what's really awesome about this is we don't really have to turn to the command line anymore, to be honest. What we could do is just download the kubeconfig and go right into the cluster. So we can use this link right here. And remember, I should say that I do have DNS set up for what would be the ingress VIP. So anything that would be apps.ccd.ai.telco.ocp.run, and then the API, right? So that's standard still. You're still configuring those. But what is different is if it is there's a couple differences. If it is, let's say, user installed provisioned infrastructure, you would have to set up the entire infrastructure, including your Bastion node, DNS server, HA proxy, etc., right? With this, what you'll notice is that there's no, well, actually that's your key indicator right here, is that the role of bootstrap is assigned to the master. So what happens with assisted installer is you don't need to set up a bootstrap node, which is separate. It starts kicking everything off in a UPI deployment. What we do, or what Red Hat does rather, is it uses one of the master nodes, or control plane nodes really, as a bootstrap host to start up the cluster, and then once, like in a multi-node scenario, once one of the, or two out of the three control plane nodes is online and ready and responding to kube commands, the APIs are up basically, then what happens is the bootstrap will reboot and then be configured as a master role. In a single all-in-one OpenShift environment rather, what will happen is it goes through a process where it will reboot a couple times, and it configures the bootstrap process. It needs the it needs the DNS entries to exist somewhere, but it will use itself as the bootstrap node, and then it will reboot into an all-in-one control plane plus worker node, which is super cool. So it reduces your infrastructure costs. It reduces the complexity because you don't need all the UPI elements. And we're doing this as if it were bare metal. So you can copy the password here and log into this this host here. And what we'll notice is when we go to workloads here, pods, if we look for the Calico workloads, what we see here is that here's the API server, the kube control. We'll make this a little bit bigger. The kube controller for Calico. Make this one more bigger. And then we've got our Calico node and Typha, right, for the auto scaling of the backend database piece. So great, Calico's here, but now what? So I'm going to go into my local pfSense box, which I use for a lab gateway. And what I'm going to do is show you my BGP configuration here. So I'm enabling BGP. And if you go into the global settings, you need to enable FRR2. This is listed as a package. So just kind of taking it from the top down. What I have is FRR is installed on this. And FRR provides a few things, right? It basically enables BGP, OSPF, and OSPF6 routing packages on a pfSense appliance. But FRR is great. We used it in other use cases at Red Hat. But what we're going to do in this case is use it with pfSense. And we're going to configure BGP. We've got a local AS of 64.512. We're setting the router ID as the first octet, so it's going to be 192.168.60.0. And then the other important thing is that we're setting up a peer, right? So the peer is going to be, or I'm sorry, the neighbor. The neighbor is going to be 192.168.60.225, which is the bonding interface for the OpenShift node. And remember, we're going to have a remote AS of 64.512 as well. Okay, so with that, what we're going to see is we'll go into status and we'll look at our BGP neighbors and see if we've got any neighbors. And when we look at the neighbors and BGP routes, what we see is I don't believe we have any neighbors here, right? So we've got one defined, but we haven't received or sent any data from that in a while. I have used this previously, but we haven't sent any data in a while. So it's not really sending any. It's not sending any routes to us. Is what I want to kind of show. Now we do have a bunch of routes that we're showing that we would be sending to that BGP neighbor. But let's go ahead and get this configured and see where we take it from here. Okay. The first thing that we'll need to do is we'll need to download the kube config, and we'll need to download the kube admin password. Right, so we store those later. And going back to our tree, that's what the auth directory here is for, right? So what we're going to do, let's go back and copy this. So we're going to load this kube config file here, and then we're going to download the kube admin password. And then we're going to do an OC get nodes and see if we've just got our one node. And sure enough, we do. Great. All right, so now what we're going to do is we're setting up to get into the Calico piece, right? So what I want to do is I want to download the Calico utility. So it's Calico CTL, and we can run that in the cluster itself as a pod workload. The way that we're going to do that is we're going to curl this, and this is coming straight from Calico's documentation, And we're going to place this into the network Calico calicoctl.yaml file. So once we've loaded that, what we're going to do is apply. We're going to apply this manifest. That's going to take just a moment to come up. But while that's coming up, what we're going to do is create an alias. And this alias is pretty simple. Anytime we call Calico CTL, we really want it to run OC, give it the kube config file here, right, for the cluster name. And then we're going to exec into where this is deployed. So it's in kube system by default. And it's going to run the command Calico CTL, right? So that way, if we need to run other commands against Calico CTL, then we can. Now what I have you doing is downloading 2 files in here and edit these to your environment, but it would be an example for BGP peers and then the BGP configuration. What I want you to do is download these files first. So we're going to copy these files here. These are just curl outputting into the Calico directory. So if we do a tree again, just to kind of show you where these end up, they end up right here. You'll apply the BGP configuration first. So let's have a look at this and see what it looks like. So what we're doing is we are disabling node-to-node mesh. So Calico does this in kind of a funny way. It's either a true or false, whether it's enabled. So node-to-node mesh enabled, false, because we want to disable it, okay? The local AS number is going to be 64.5.112. We're giving it the CIDR ranges, so the things that you want to advertise or configure. I'm configuring the service cluster IPs for the 172.30/16, which is default, actually, for the config here. And we're going to set the log severity to info here. This is going to be default BGP configuration. So what I'm going to do, since Calico Cuttle, we'll just call it Calico Cuttle from here on out, is deployed as a pod workload, we need to redirect any of the standard input, basically, into the Calico Cuttle command, right? So what we're going to do is Calico Cuttle create from a file, and then we're going to redirect that file into that command. That's how we're going to deploy our resources. So if I were to say Calico Cuttle CTL get BGP configuration, the name is default, and then let's output that to YAML, and we can see that that's been applied, right? Because we've got a resource version and a UID associated with that. Great, cool. So we've disabled node-to-node mesh, which is required for BGP peering. It's in their instructions. And then what we're going to do is configure a BGP peer. So if we were to cat network Calico, if we look at this, what we're doing is we've got our AS number here, same as before. We're setting the peer to 192.168.60.1. And what that does is that maps directly into what we've got configured. Let's go back here for a second. For our BGP router ID, right? So that's who we want to peer to. So what we're going to do is then configure our BGP peers. And I kind of want to get this ready before we actually commit it. So if I go into here and I look at status for BGP neighbors. Okay. So BGP neighbors right here. Again, we haven't received anything. So what I'm going to do now is apply that. And you can do a Calico DL get BGP peers. And then we're just going to output at anything we get into YAML. So here it is. Got that. Now, if I refresh this page, I would expect to start seeing some data here. Messages received. This is good. now we're getting updates from our BGP host. And we should be getting routes here too. We are getting routes now for a host here. Great. So we're receiving from 192.168.60.25, 225, sorry. So what does this actually mean? Okay. Like at the end of the day, what's the big deal about this? Why do customers want to use this? Or why do people want to use this rather, right? So let's say I want to look at my pods for an example, and each pod is going to get an IP address, right? So if we were to look at, let's say we look at the cluster IP for these things, like in this case, we've got a pod IP of 10.131.4.12. I should be able to ping this address and reach it directly. Why would somebody want that? Latency is one. Maybe they just want to go directly one hop or next hop using IP, just L3, right? Troubleshooting. They may want to cut out the ingress side and do direct troubleshooting to the pod IP addresses themselves. That's a use case that's commonly used. And IP is fairly simplistic. Like if you want your routes to just be advertised as native IP addresses, then this would be the way to do it. So in summary, what we've covered is quite a bit. We've covered how to use the assisted installer at a more granular level, configuring network IP addresses, configuring your bonding IP addresses, configuring Calico as a default CNI. So I really want to stress you should get into advanced usage with the assisted installer. Try it out. Let me know what you feel. Let me know if you like it or if you have questions. Please put them in the comments below. It's been great talking to you today. I really enjoyed my time sharing some ideas with you, and I look forward to any feedback you have. Again, my name is Brandon Joza. I'm a solution architect with Red Hat in the Tiger team for the America's Telco Media and Entertainment Group. And I hope you have a wonderful weekend, or whenever you're viewing this, I hope you have a great week, and we look forward to seeing you soon. Take care.